In our last video, I explained the problems in normal distribution. In every problem, we have seen how to convert given normal variable into standard Z variable. And with the help of this Z and the table, we are calculating the required probability. Now, in this video, I will take few applications. In this example, for the 1000 students, main mark 34.5 and standard deviation 16.5 are given. Now we have to find the total number of students between 30 and 60 marks. To find this, first we write the given values. What are the given values here? The mean mark of the 1000 students. Okay. So here given the mean mark of the 1000 students, that is 34.5, and the standard deviation, it is 16.5. Now we have to find total number of students in between 30 and 60. Okay, for that just we have to find the probability of the variable x lies in between 30 and 60. Already we know the procedure. To find the probability, first we convert the value of x into standard variable z. So here first x value is 30 and corresponding z value. Already we know the formula, x minus mu by sigma. So this is equal to, what is x here? X equal to 30 and mu equal to 34.5 by sigma, standard deviation 16.5. So the value is, okay, if we simplify this, we can find minus 0.27. Next x value, that is 60. Now z equal to x minus mu by sigma. So 60 minus 34.5 by 16.5. So this is equal to 1.54. Okay, these are the x values. Now we calculate the probability when x lies in between 60 and 30. Okay, we can also write the same thing as P of minus 0.27 less than or equal to z less than or equal to 1.54. To find this probability, we need normal distribution table. So what is the normal distribution table here? See, from normal distribution table, we can find the probability. Before that, first we draw the normal curve. See, in this normal curve, look here, we have to find the area between these two z values. So here z equal to minus 0.27 and here z equal to 1.54. Already we know, if z is negative, you have to mark left to the main line. If z is positive, you have to mark right to the main line. Okay, we have to calculate here the area between these two lines. So this is the required area. To find this area, we can do one thing. I will take separate graph for each value. See, first I am taking 1.54. Already we know from z table we can obtain the left side area of the z. Okay, so from the table what we will get, the left side area. Left side area means you will find this area. Okay, from table you will find this area. Okay, this is the area we can obtain from the table. Okay, if you see the table, from the table you will get here 0.9382. Okay, this is the area from the table. Next, suppose if we take the next second value minus 0.27. So what is the result? Minus 0.27 means we can find here minus 0.27. Okay, the left side area of the z, always we have to consider the left side area of the z. Okay, this is the area. Okay, the value of this area from the table is 0.3936. Okay, now see, we have to find the area between minus 0.27 and 1.54. See, from this total area we have to subtract this part. Okay, that gives the required area. So what is the value here? So total area, what is the total area? 0.9382 minus 0.3936. Okay, that result, what is the difference? 0.5446. Okay, this is the required probability. See, we are following the same procedure what we discussed in the last video. Okay, so but what is the question? We have to find the number of students between these two limits. Okay, to find the number of students between these two limits, we can write here, this is the probability. 0.5446 is the probability that total number of students lies in between 30 and 60. Okay, you can also write 54%. Now we need the total number of students. Total number of students between 30 and 60. Okay, it is very simple. Just you have to multiply this value with 1000 because total strength is 1000. Okay, if you multiply this, you will get here 544.6. Okay, this is the required value. So we can consider the total number of students as 544. Okay, see, to find the number, we are calculating probability first. Then we have to multiply with the total count. That gives the required value. You can also see the table here. How to see these two values in the table, 1.54 and minus 0.27. Now you can see the table. In this table, we can find the area left to the 1.57. Okay, so what is the value here? See, I am taking again the graph. See, what is our z value? One z value here. The z value is, say it is positive, so I have to write on right side. So this is 1.54. Okay, now from the table we can find the area left to this z value. Okay, this is the area we can find from the table. So what is this area from the table? Okay, you can see here z values, always you have to see in first column. 1.5, you can see 1.5 here. 1.54, okay, you can see that 4 here. Corresponding value, okay, you can see the corresponding value. What is that? 0.9382. Okay, we have used the same value in our problem. And for negative we have to take the negative table. Okay, what is the z value? It is a negative value, so we have to mark on left side. The value is minus 0.27. Okay, already we know left side area of this z value. From the table, see, you have to see minus 0.27. On first column, minus 0.2. Here you can find it. 7 on top row, you can see the 7. Okay, corresponding value, that is the area. Okay, you can see here. So what is the area value here? 0.3936. So this value is 0.3936. We have used the same value in our problem. Okay, see, the table, how to find the area or probability from this table. In this example, the marks obtained in mathematics by 1000 students are normally distributed with a mean 78% and standard deviation 11%. So first we write the given values. What are the given values? Given mean means mu equal to 78%, so 0.78. Standard deviation sigma equal to 11%, 0.11. First question, how many students got marks above 90%? How many students got marks above 90%? So here x equal to 90% means 0.9. Okay, we can convert this x value into standard z value. Z equal to x minus mu by sigma. If you substitute all these values here, you will get 1.09. This is the standard z value. Now what is the question? Probability of x greater than 0.9. Okay, this is equal to probability of z greater than 1.09. See, if you see the normal table, see, before going to find the value, first we have to draw the normal curve. See, this is the normal curve. You can see 1.09. 1.09 means we have to mark on right side. So this is 1.09. Okay, greater value means this one. See, z greater than 1.09. We need this area, this blue color area, but the table always gives the left side area. From the table, what we will get? This area. From table we can find this area. Okay, so by seeing the table we can find this area as 0.8621. Now what is the required value here? See, already you know total area under the curve is 1. So 1 minus 0.8621, that gives 0.1379. Okay, this is the required probability. Means 13.79% of the student. Now the total number of students. See, what is the question? How many students got marks above 90%? Okay, above 90 means greater than 0.9. That is, we got the probability, not total number of students. So the total number of students we will find now. Number of students. Okay, we have to multiply this probability with 1000. 0.1379 into 1000. So what is the result here? 137.9. It is almost equal to 138. Okay, so 138 students got more than 90% marks. Now the second question. What is the second question here? What was the highest marks obtained by the lowest 10% of the student? Okay, if you observe here, see, given the total percent of the student, now we have to identify the highest mark in this bound. See, we have to calculate. We don't know what is x here. Okay, we have to find x value. I will show the figure here. Now look here. Lowest, what was the highest mark obtained by the lowest 10%? Lowest 10% means I have to take the 10% of the student on left side. Okay, already clearly mentioned that lowest 10% students. Okay, so I have to consider that area on left side. This is the lowest 10% student. Okay, this is 0.1. See, already you know from the table we can obtain, if you know z value we can obtain area. If you know the area we can obtain z value. See, in the second problem we have area, now we need z value. Already you know table gives always left side area. So if you see this left side area in the table, then the table gives z equal to minus 1.28. This is the z value. See, by using this Z, we can find X value. Already you know the formula for Z. What is the formula for Z? Z equal to X minus mu by sigma. Yes, Z equal to minus 1.28 and X unknown value mu equal to 0.78 by standard deviation 0.11. After simplifying this equation, X equal to, we can obtain 0.6392. Okay, this is in percentage. So what is the exact value? X equal to 63.92. Okay, now look at that. What was the highest marks obtained by the lowest student? That is 63.92. This is the highest mark obtained by the lowest 10% students. Okay, in 0 to 63 you can find 10% of the students, and 63 is the highest mark in this range. Okay, now we take the third one. What is the third one here? What within what limits did the middle of 90% of the student lie? Okay, you can see within what limits the middle of 90% student lie. Okay, see 90%, middle of 90% student. So I have to take the middle value, middle area. Okay, this is the given area. This total value is 90%. 90% means 0.9. Okay, this is 0.9 means what about this one? This is 0.05 and this is also remaining area 0.05. Okay, total area is 1. So this is 0.01 and this is 0.05. See, if you see this left side area in the table, you will find this Z value. Here Z value is minus 1.64. See, this is the symmetric. So here Z is also 1.64. Okay. Now, what is the question here? Within what limits did the middle of 90% of the student lie? Okay. For this range, what are the X values? Okay. What is the lower bound and upper bound of the X for this range? To find X values, first I will take this left side value, Z equal to minus 1.64. Okay, already you know Z equal to X minus mu by sigma. Here Z equal to minus 1.64 equal to X minus X is unknown, mu 0.78 by sigma. Sigma means 0.11. See, after simplifying this, we can find X equal to 0.5996. Okay, similarly for the second bound, right side bound for this region. Okay, see this right side bound is, this one is the right side bound. Okay, now Z equal to, again same formula, X minus mu by sigma. So Z equal to 1.64 equal to X minus 0.78 by 0.11. So by solving this, we can find X equal to 0.9604. Okay, now what are the bounds for this 90% range? Okay, see these are in percentage, so you have to convert into decimal, so decimals to numbers. Now you can see here. Okay, lower limit is X equal to, you can we have to multiply with 100 and you can write here. So your lower limit is X equal to 59.96 and upper limit is X equal to 96.04. Okay, for this 90% range, for this range, okay, 59.96 is the lower bound and 96.04 is the upper bound. Okay, within these two limits you can find 90% of the students. Once again, you can see how to use the table. In our last problem, see what is Z? Z equals to, in one case it is 1.0 0.09. Okay, in this table, see, you have to see Z value 1.09. In first column, you have to see 1.0. See, this is 1.0 in first column. 0.9. 9 means on top row you can see here 0.9. So this is 1.09. What is the corresponding area? Okay, you can see here. So this is the corresponding area, 0.8621. See, already you know this table gives the left side area of Z. So you will find this area. This area is 0.8621. See the another table for negative Z values. We use this. See, in our last example, we have Z equals to here minus 1.28. Okay, now you can see in first column minus 1.2, you can see here minus 1.2. Okay, minus 1.28 Z value. So 8 on, you have to see on top row. Okay, corresponding area, you can look at this. See, this is the corresponding area. We know that is the left side area of the Z value. So this value is Z equal to 0.1003. Okay. So this is the procedure to see the Z table. Now you can see another example here. A sales tax officer report. Okay, what is the report? Is the report saying that for 500 business he is getting average income. Okay, that is 36,000. Okay, with the standard deviation of 10,000. So we can write down the given values first. Given mu equal to 36,000 and standard deviation equal to 10,000. Okay, now what we have to find here? We have to find the number of business as the sales of which are 40,000. Okay, to find this first we define the random variable. Now we can say the random variable as, okay, this random variable denotes the sales in the business. Okay, from the business we can write the total sales, that is random variable X. Now I am taking the first question. See, in this first question, what is the question? Once again you can see here the number of business as the sales of which are 40,000 means if X equal to 40,000, okay, you have to find the number of business. Okay, this is the question mark. See, to find this value, first we have to find the corresponding probability. So I have to calculate the probability first. For that we convert this X into standard Z variable. Already you know formula, Z equal to X minus mu by sigma. So what is X here? 40,000 minus mu, 36,000 by sigma, 10,000. Okay, so we can find here 0.4. To find the probability, so we can write down here probability of X greater than or equal to 40,000. Okay, see, immediately you can get one doubt here. I have written X greater than or equal to 40,000, but the question is X equal to 40,000, but I have written greater than or equal to 40,000. Why? Okay, I will give you a simple example. Suppose you are expecting 80 marks in the exam. Okay, and you got 81. What about your expectation? whether it is right or wrong. Absolutely it is right. If you got 82 or 83, 84 means more than 80, 80 or more than 80, then your expectation is right. Okay. Suppose you are getting 79 or 78 or 77 means less than 80 means your expectation is wrong. Okay. So that's why what he is expecting 40,000. Suppose if we get more than 40,000, then his statement is right. Okay. So we can write down here x greater than or equal to 40,000. Now, probability of x greater than or equal to 40,000. How can we calculate this? By using z standard z variable. So its equivalent to expression is probability of z greater than or equal to 0.4. Already you know how to find probability by using z table. To use the z table, first we have to draw the normal curve. See, in this normal curve, I can write. See, first I have to mark the z value. Already you know if z is positive, always we have to mark on right side. So 0.4 I have to mark right side. Okay. Now we have to see the table. Already you know table always gives the left side area of z value. So the left side area means this one. You will get this one from table. Okay. Already you know how to see the table. From table you will get here 0.6554. Okay, but what is the required probability? P of z greater than or equal to 0.4. Okay, greater than means we need the right side area, but table gives left side area. So how do you get this right side area? Already you know under the curve the total area is 1. Okay, to obtain this area, very simple, you can take 1 minus 0.6554. So what is the value here? 0.3446. So this required probability is 0.3446. Okay. Now, actually this is not a final answer. We have to find the number of business. To find the number of business, it is very simple. We have to multiply this probability with the total number of businesses. Okay. So what is the total number of business? That is 500. So we can obtain here 500 into. So we can write down here in this first case the number of business. Okay. For this sales, that is 0.3446 into 500. So the value is, what is the product here? 172. The approximate value is 172. Okay. From 172 business, he can obtain 40,000 amount. Okay. Now the second one. What is the second one? The percentage of business, the sales of which are likely to range between 30,000 and 40,000. Means we have to find in the second one, we have to find probability of 30,000 less than or equal to x less than or equal to 40,000. Okay. See, the sales lies in between 30,000 and 40,000. Okay. Already you know, we convert these two x values into z, standard z. When x equal to 40,000, already we have z equal to 0.4. Now we find z value for 30,000. So if x equal to 30,000, what is z? Z equal to, again you have to use the same formula, x minus mu by sigma. By substituting all these values, you will get here minus 0.6. Okay. Now, to find this probability, you have to calculate probability of minus 0.6 less than or equal to z less than or equal to 0.4. Okay, you know this. See, to find this probability, see already I have one curve here. See, I can, okay, already you know. See, suppose for negative z value, always we have to mark on left side. Positive z value, we have to mark on right side. Now we need the area between these two numbers, these two z values. Okay, the z table doesn't give this value directly, already you know. Okay, first we have to see from z table what will you get. Suppose z equal to 0.4, you can find this left side area. Okay, already we have that area 0.6554. Next, okay, I have to remove this. Okay, so z equal to negative value. Negative value means you can get the negative value here, minus 0.6. If you see minus 0.6 in the table, you will get this one. What is this? Okay, if you see minus 0.6 in the table, you will get here 0.2743. Okay, from this total area, you have to subtract this part. Okay, because this is 0.4. So we need this area. So from this total area, you have to subtract this part. That gives the required value. So this is equal to, I can write down here, 0.6554 minus 0.2743. This is exactly equal to 0.3811. Now look at the question. What is the question here? You have to find the percentage of business in this range. Okay, so what is the percentage of business here? The percentage of business in the given range, that is, see, by using this probability we can write the percentage, that is 38.11%. okay, this is the required answer. Now you can see the another example. This is the statement of one manufacturer. See what he is saying. He is making the resistors and the average, you can see here, with the mean of 100 ohms. So the average resistance is 100 ohms and the standard deviation is 2. So what are the given values in the data? Given mean equal to 100 and standard deviation equal to 2. Okay, now the question, it is very simple question. What percentage of resistors will have resistance between 98 and 102? So what is the random variable here? So we can define the random variable as, okay, this represents resistance of resistors. Okay, this is the random variable. Now the question is, suppose X lies in between 98 and 102. So what is the percentage? If X lies in between these two numbers, what is the percentage, okay, of resistors? Now look here. To find this, first we convert these two X values into standard Z variables. Okay, if X equal to 98, then Z equal to, already you know the formula, X minus mu by sigma. So we can obtain 1. If X equal to 102, then Z equal to 1 with the same formula. We have to calculate probability of 98 less than or equal to X less than or equal to 102. Its equivalent probability of minus 1 less than or equal to Z less than or equal to 1. Okay, to find this probability, again we use the normal curve and Z table. To use the normal curve, you can see here, already you know. Negative values always we mark on left side and positive values we mark on right side. Okay, so what is the required area that lies in between z equal to -1 and 1? This is the required value. Okay, to find this value, first you have to see the table. Okay, in the table you have to see -1. So z equal to -1. If you see -1 in the table gives this left side area. Okay, always the table gives left side area of z value. Okay, this area is 0.1587. Okay, now the next one, if z equals to 1, if you see in the table gives the left side area of z equals to 1. So this is the area we can obtain from the table. So this value is from the table 0.8413. See, what do you need here? The area between these two, -1 and 1. So it is very simple. From this total area, you have to subtract this part that gives the required value. So what is the required value here? 0.8413 minus 0.1587. This equal to 0.6826. See, this is the probability. Okay, when x lies in between 98 and 102, the probability is 0.6826. Okay, now the question is we have to find the percentage. See, we have to find the percentage of resist. See, you can see here what percentage of resistors will have resistance between 98 and 102. So it is very simple. For the required percentage, we can multiply this probability with 100. So that gives 68.26%. Okay, so the 68.26% of resistors will have resistance between 98 and 102. This is the final answer.